Problem 52 is another application. This one involves a three-dimensional rectangular box, so I thought it would be a good opportunity to just review the geometry associated with that shape. So we're told that we have a closed box. If it's closed, that simply means it has a top. Okay. Sometimes we'll work with an open box. That would have just a bottom and 4 sides. A closed box has a total of 6 sides because you've got the top and the bottom, front and the back, left and the right. Okay, so we're told that we have this closed box in the shape of a rectangular solid, and we're given the height is 3 meters. Okay, and then I've just labeled the other 2 dimensions, x and y. If you wanted to label them length and width so that you've got length, width, and height, that's totally fine. I'm going to go ahead and write in that that was meters, though. That's the units for this problem. Okay, so then we're told the surface area is 268 square meters. Area is always in square units, okay? And the surface area is just the sum of the 6 sides, okay? And then we're told that the volume is 240, and notice that's cubic meters. So lengths are always just plain old regular units like meters. Areas are square units like meters squared. Volumes are cubic units like meters cubed. Okay. Now, formula for volume is pretty straightforward. That's just the product of the 3 dimensions, length times width times height. So 3xy is 240. Let's figure out the surface area. We said that was the sum of the areas of the 6 sides. So with the sides, we're going to have the front and the back. Now, here's the front right here. That's x across and 3 meters up. Okay. So that's got an area of 3x, but we have 2 of them because we've got the front and the back. So 2 copies of 3x would be 6x. I'm just going to make a note. I got that by taking 2 copies of 3x. Let's do the top and the bottom. Okay. The top is right here. That's this by this. This is x across and y back. So the top and bottom have dimensions x and y. So the area of one of those is just x times y. Again, I've got 2 of them, so it's going to be 2xy. And then we've got the left and the right. Well, here's the right side right here. Notice that's 3 meters tall and y meters back. So the area of one of those would be 3 times y. Again, I've got 2 of them, so that's going to be 6 copies of y. 2 copies of 3. Excellent. So those 2 properties of our rectangular box give us our 2 equations. Now both equations do contain some xy's, but I don't think I want to use addition to eliminate those, because if I got rid of the xy's, I'd still have x's and y's. There's no one type of term I can eliminate in order to have just one variable left. So I'm going to want to use substitution, and I think I'm going to work with this simpler equation. I'm going to just solve for x. To do that, I would divide by 3y. Now, as a general rule in math, I don't like to divide by variables in case that variable is 0. In this case, I know that y isn't 0. You can just see that from my picture. It's a dimension of a box that's actually taking up some space. So it's going to be a positive number. I can also see algebraically, if I'm multiplying y by something and not getting 0, I know that y is not 0. Okay. So it's okay to divide by it, and that's going to give me that x is 80 over y. Okay, so I'm going to plug that into my other equation. The other equation was this surface area one, and I'm plugging that in for x. So we'll have 268 is equal to 6 times x. So I'm just going to write that 6 as 6 over 1, since I'm multiplying it by a fraction, 80 over y, plus 2xy. So that's 2 over 1 times x is 80 over y times y, which I'll write as y over 1, plus 6y. Okay, so let's see. That's 268 is equal to 480 over y, plus here these y's cancel, and I get just 160 plus 6y. So I've got this equation. Never too crazy about having variables in the denominator. I want to get them out of the denominator before I can solve this thing. Okay. So I'm just going to multiply both sides by y. So we'll have 268y is equal to. Now when I distribute the y to this piece here, it's going to cancel. So I get just 480. Then I distribute it here, so that's plus 160y. And I distribute it here, and that's plus 6y squared. So it looks like we've got a quadratic in y. Let's move over this 268y. I'm going to just copy things, and actually give myself some more space. I'm going to copy things over here, and as I do that, I'm just going to write the right side in descending order. So we'll have 0 is equal to 6y squared. This is going to be minus 108y plus 480. Now, that's some kind of big numbers that we're working with. Okay. So I'm going to just notice that all of the numbers in that equation are even. So if I want to, I can divide both sides of my equation, that means each and every term, by 2. That's just going to make the number smaller. So I'll have 0 is equal to 3y squared minus 54y plus 240. Okay. Still a kind of big number, but I'm going to try to do this by factoring. Of course, if you prefer, you've got the quadratic formula or completing the square. To get a 3y squared, I'm going to have a 3y and a y. The numbers that go here have to multiply to give me 240. So over here, I'm going to just create a list of factors of 240. Okay. I can see they're going to have the same sign to get positive 240. And if the outsides and insides are going to give me something negative, they're going to have to both be negative. Whatever number goes here, I'm going to multiply by 3 before I add it to one copy of the number that goes here. And I want that sum to be 54. I'll just make a note that both of these numbers I'm going to be subtracting. So let's just list pairs of factors. 1 and 240, I can see that's way too big. 2 and 120, 3 and 80, 4 and 60, 5 and 48. Okay. Okay, and again, I'm hoping that one copy of one plus 3 copies of another adds to 54. Okay. 6 and 40. Notice we're getting close because 3 copies of 6 would be 18 plus 40 would be 58. We're trying to hit 54, so I'm getting close. 7 doesn't work. 8 and 30. Let's see, 3 copies of 8 would be 24 plus 30 is 54. It works. So I want to put the 8 here so that I'm multiplying it by 3 and the 30 here. Let's do a quick double check. First terms give me 3y squared. Outsides are negative 24y. Insides are minus 30y. Those combine to give me my negative 54y. Last terms give me plus 240. Nice. Okay. So 3y minus 30 equals 0, or y minus 8 equals 0. This would mean 3y equals 30, so y equals 10. And this would mean y equals 8. Okay. Now, remember that when we solved for x, we got that x was equal to 80 divided by y. So, if y is 10, x becomes 80 divided by 10, which would be 8. And if y is 8, x would become 80 divided by 8, which is 10. So I can see what happened in this one is the same thing that happened in the last one. It looks like I'm getting two answers, but the dimensions are really, it's going to be 10 meters by 8 meters by 3 meters. Okay, it's just a question of which side am I calling X and which side am I calling Y. Okay, and it doesn't really matter. One of the sides is going to be 10 meters, one of them is going to be 8 meters, and of course the height was 3 meters. So make sure we give our dimension, our answer, our question, our dimensions are 8 meters by 10 meters by 3 meters, where this dimension was given, and these are the two that we just found.